Hi everyone, my name is Vasily Malanin and I'm head of IoT business development for Amazon Web Services in Asia Pacific region. So welcome to our first episode of the AWS IoT Digital Roadshow for Asia, where we discuss solutions to accelerate Industry 4.0 journey. There will be 3 episodes, and in each of them, I will be joined by some great speakers who will show you some exciting demos and explain how we jointly can help you to optimize your industrial operations, drive productivity, quality, and availability of your industrial assets. To explain the logic behind the selection of the topics, let me actually step back and share what we hear from our customers about the environment we are in today. So industry is changing through the use of technology. You see, most of our customers are rethinking their products and add some sort of smart functionality or evolve their business models by adding value-add subscription-based services. So this actually generates a lot of data, and this data is used to analyze the usage trends and ultimately build better and more desired products. On another side, as we recover from the pandemic, industrial customers and manufacturers in particular experience a lot of pressure. There is a high demand for products in particular verticals, for example, in healthcare and pharma. There are shortages of silicon that many of you already observed. So it creates some challenges in high tech and semicon industry. In many verticals, we see that there are still challenges to fully staff the production, and it all drives manufacturers to basically squeeze every drop of productivity from their existing assets, while obviously making sure that the environment is safe for the employees and also fits the sustainability criteria that is coming up from the governments and from the citizens of the countries. Now, this time we want to focus on the manufacturing side, right, on operations. And typically, when we speak with our customers about the smart industry, about driving operations with the help of technology, we start with the business outcomes. So what are the things that we want to achieve by using data analytics, by using IoT? And there are some high-level buckets that most of the projects will lend to. And ultimately, these are the outcomes that every manufacturing manager, plant manager, shift manager is measured upon, right? So things like productivity, quality, availability, like together, as you know, they form one of the key manufacturing KPIs, which is overall equipment effectiveness. And as you can see from the titles of our sessions, we kind of designed our content around these 3 areas. So in today's session, we will be focusing around productivity. Next time, we will be diving deeper into availability. And finally, in the 3rd session, we will look much deeper into availability. Though generally, there is a cross-pollination between different projects and the projects that are primarily driving productivity will also result in improved quality and availability. One interesting observation that we did is that, while it's hard to achieve really high numbers like 40% in productivity or 30% improvement in quality that you see on this slide, it comes through a series of improvements, right? So it's a part of your continuous improvement initiative. But even, some simple steps like getting the visibility, near real-time visibility into the manufacturing KPIs can help plant managers, production managers to improve productivity by 5-10%. There are a few other things that are also high on the agenda for our customers, such as the utility cost and safety. And these are also very important projects that we typically help our customers with. There are a set of solutions that cover this area, and we will be happy to dive deeper into that with you if you have those requirements. So as I said, think about the business outcomes that you want to achieve, and let's work on the roadmap, how we can improve your productivity, quality, availability, utility cost, and safety. Now, let me just quickly talk to you about why AWS for industrial, smart industry, for manufacturing. So AWS is a cloud provider, and we were born by driving operations for our parent company, for Amazon, which is the largest retailer in the world with largest e-marketplace. So AWS was born from complex operations and sometimes even factory operations at Amazon. So if you walk into any facility where we do sorting, where we do fulfillment of the orders that we get from the customers online, it looks like a factory. It has kilometers of the conveyor belts, it has motors, robo arms, shelves. So all of those things that you expect to see from a manufacturing facility, you're going to find there. And AWS was at the center of the initiatives to improve the effectiveness of those operations in the facilities. AWS has the most comprehensive, advanced set of services and features available today. Many of them are actually built for manufacturing specifically. So there are AI and ML services and models that are tailored for things like predictive maintenance or quality control. There are databases technology that are specifically tailored for time series data, which is basically one of the staples for industrial analytics. So you will find a lot of ready components that you'll be able to use in your industrial projects. AWS meets security requirements from healthcare industry and financial services, and even some top secret government applications are hosted on AWS. So we take security very, very seriously, and you can take advantage of this security knowledge that AWS acquired over the years. And so many of the manufacturing organizations are now moving their IT infrastructure, now connecting their shop floor, the OT data sources to the cloud, and start using our features to analyze the data. And finally, AWS has a massive global scale, which reduces your risks because it ain't gonna anywhere. And it also drives cost efficiencies, right? The economy of scale is known to provide the best cost structure for the customers like you. One more important element that is not yet listed on this slide, but it's going to be a big focus for the series, is our partner channel. So we have amazing partners who use all the benefits of AWS and make it easy for the customers to deploy very complex automation and industrial solutions on AWS. So I just wanted to give you a very brief view of what services and what capabilities the AWS actually provides to the industrial use cases and industrial customers. I mentioned that we have a very broad set of services that we provide to the customers. And typically you need to bring together a set of services and build a solution that implements your business case. So we typically start with the business outcomes and then move backwards to the technology solution, technology architecture. On this slide, you see a high-level like a reference architecture of what we see with many of our industrial customers. So they want to achieve outcomes such as production and asset optimization, quality management, safety, and so on. So for that, they use analytics, visualization, data, a platform that is hosted in the cloud. They also leverage the rich set of services that we provide specifically for industrial context to ingest the data from shop floor, from your industrial assets, from the industrial protocols such as OPC UA, Modbus, Ethernet IP, and others. And obviously, to support this, we had to develop a pretty rich edge layer that works at your factory edge in your shop floor environment that would basically connect to all those machines that we're talking about. It will connect to all the data sources such as MES, SCADA systems, your DCS systems, PLMs, and things like that. Now, in certain cases, our customers also want to have certain operations done in offline mode, right? So without basically connecting to the cloud. So this functionality is also now supported, but with this, you need to find the right balance between what you want to do on-premise and what you want to collect and process in the cloud. Because at the end, when we speak about industrial analytics use cases, you want to collect, you want to process, you want to reason on top of a lot of data to make sure that you can derive some interesting insights. So I already mentioned that there are a few ways how you can work on these solutions, on industrial solutions in AWS. You can take those services and build AWS solutions yourself, right? So if you have the developers, if you have advanced IT department who's familiar with the cloud, then you can definitely go ahead and build your solution. We have a lot of white papers, solution starters, reference architectures that can help you to do that. However, in many cases, especially in industrial and manufacturing space, we see that the customers want to get help from our AWS partners as well as our professional services organization. So another way is to engage with AWS partners and AWS professional services to deploy a solution that you require for your factory or for your industrial operations. And we do have different sets of partners. Some of them would actually help have ready-made solutions that you can basically just take, adopt, modify for your own environment and start using with relatively quick runway. So over the next 3 days, over the next 3 sessions, we actually will be sharing with you the insights from our partners who have such solutions and who have experience of building real-life industrial analytics and smart factory projects. And with this, let me introduce our next speaker. His name is Subbu Hatwari. He's a CTO of a company called WebSim, one of our close industrial partners in Asia Pacific and Japan. Subbu, over to you.
Thanks, Vasily. So I'll start off with an introduction to WebSim, and then we will talk about the FactoryWise solution that we have, which is primarily used for the smart factory or connected factory implementations. WebSim is a 6-year-old company. We primarily work in the industrial IoT segment. We have 2 solutions that we offer to customers. The first one is FactoryWise, which is targeted towards the end user manufacturing organizations. And the second one is Tezera, which is targeted towards OEMs and machine builders who want to monitor the health and performance of their assets which are deployed in the field. So coming to FactoryWise, let us try to understand why an organization would need a solution like FactoryWise. Primarily, the main business driver for considering an Industry 4 or a smart factory implementation is to get real-time visibility into your manufacturing operations. And with this visibility, the decision makers in the plant get a opportunity to intervene in real time whenever there is an issue that is identified and try to reduce the losses that occur because of these issues. The second business driver that we have seen with our customers is to reduce the use of paper and manual data recording that happens in a traditional plant layout. They want to have paperless environment with data being acquired electronically with as little of human intervention as possible. This improves the data accuracy and also ensures that the reports and the KPIs that get generated, which are the basis of their process improvement or performance improvement initiatives, they are based on a solid baseline. The third area where people are looking at is to improve process compliance, especially in the case where process optimization is required. They would like to understand whether the standard processes are being followed, whether there are any deviations, and then use this information to try and improve their processes. The fourth area that is of interest to customers is operational safety. Everyone is interested to make sure that the plant environments are as safe as possible with the minimum number of accidents and incidents that occur. So they would like to use IoT technologies to ensure that any deviation in terms of the use of equipment or the deviation in safety policies can be identified and intimated to the safety officers in real time. The last area that we have seen customers talking about is to improve their supply chain visibility. This is specific to certain sectors where a lot of the manufacturing is outsourced, and customers want to get visibility not only into their own operations but also into operations of their vendors to make sure that there is as less of inventory being maintained as possible. The end goal of all of this is also to be in a position where the data that is acquired gets used to build models that can predict process yield, can be used to improve performance, reduce the downtime of equipment, and so on. And as a whole, once you look at all of these business drivers, a connected factory solution is something that makes sense to most of the manufacturing customers. To address all of these business drivers, we have developed the FactoryWise Connected Operations platform. This is a suite of modules that can be implemented by customers. There are 6 modules in total. We have the production monitoring module, which is the primary module. And then in addition to that, we have the quality management module, the maintenance operations module, the utilities monitoring module, track and trace. And we have also now started a new model which is primarily used for workforce tracking. So in a whole, if an organization implements all of these modules, then we are able to satisfy most of the requirements that are related to a smart factory initiative. FactoryWise is built natively on the AWS IoT stack. It is a completely serverless solution that can be scaled using the underlying AWS infrastructure. In terms of providing a real-time insight into the manufacturing operations, we have something which is called as a manufacturing cockpit. Using this cockpit, the decision makers in the plant as well as in the corporate get a single unified view of operations across all their plants, whether it's in a single country or in multiple geos. In terms of the implementation of this platform, this can be done in phases, or it can be a big bang approach taken by customers as the need may be. We'll now go into the individual modules that we just talked about and see what are the salient features of those modules and how these can be implemented. So the primary module is the production monitoring module. The intent over here is to generate the metrics which are of importance to the line supervisors, the plant managers, who can then provide guidance to the workmen in the shop floor to ensure that there are no stoppages of the line or there are no breakdowns. In order to do this, what we do is we acquire data from the controllers of the equipment and then marry this data to the data that we ingest from line of business systems, primarily the ERP as well as the production planning engines, to generate metrics like the OE metric that Vasily talked about earlier. In addition to that, there are some other KPIs that also get generated in terms of identifying the machine performance or the line performance. We also look at downtime analysis for the equipment. This is to ensure that any unidentified downtime instances are recorded and then suitable action can be taken to reduce the instances of these unplanned downtimes. With the data that we gather, we also generate SPC charts. These are statistical process control charts that are useful to determine whether the process is within control or outside of control. And in case it's outside of control, we'll delve into the reasons of why it is outside of control and then take corrective action to ensure that the processes are streamlined. A lot of the metrics that we generate are disseminated through the web portal in FactoryWise. In addition to that, we've also had customers who request us to ingest this data into their enterprise collaboration platforms, typically something like Slack or Teams. In those cases, the alarms and notifications that get generated for anomalous conditions that are detected, these are then disseminated through these enterprise collaboration platforms as well. In terms of integration with the ERP as well as the production planning engine, we provide a authenticated REST API interface through which data can be ingested from these systems and also exported from these to these systems to ensure that there is a seamless data exchange between all the systems in use in the plant. The second module that we have is the quality management module. The intent of this module is to automate the quality operations as much as possible and also to enforce the policies, inspection policies that have been defined for the various operations that are being carried out in the plant. Over here, we also integrate with quality testing equipment which have a communication interface in order to ensure that the test data is ingested automatically without any manual intervention. When this data is ingested, it generates statistical quality charts. Typically, in most of the manufacturing organizations, you would have quality inspectors who are using X bar R charts, P charts, or C charts in order to ensure whether the output of the process is within the defined tolerances or if any corrective action is needed. The production monitoring module and the quality management module typically gets implemented together. There is a feedback mechanism that is built in, wherein the test results are communicated back to the operators who are working on the equipment, and they can then take the required corrective action to address the issues that have been found during the test cycles. Again, this provides opportunity to the line supervisors to intervene in case the operators fail to take action, which would then result in additional rejections in the process. The third module that we have is the track and trace module. The goal of this module is to minimize the amount of work in process inventory within the process. In addition to that, when the material flow is not streamlined, a lot of time is spent in identifying the where the material is placed when a job is scheduled for production. So with the track and trace module, we ensure that we have visibility into the location of the work in process inventory to minimize the time that is spent in searching for this material. In addition to this, organizations are also interested to get notifications whenever the value of the work in process inventory exceeds a certain threshold. So there are these notification mechanisms built into this module where the thresholds can be defined for the maximum levels of work in process inventory that need to be maintained. And then this can then be used for alerting the requisite people whenever this level goes above the defined threshold. We have recently added an extension to this module, which is for tracking the workmen within the plant. This is especially useful for hazardous industries like oil and gas or chemical plants, where physical barriers between the hazardous areas and the non-hazardous areas are difficult to put in place. In these cases, the plant managers need a system wherein they can be notified whenever a person who doesn't have the right level of skills or the right kind of certifications enters a hazardous area, which would then potentially result into a safety incident. To address these kinds of issues, we now have a mechanism through which the location of workmen within the plant can be tracked in real time, and any deviations from the policies can be then identified and the relevant audience can be notified. The fourth module that we have is for maintenance operations. The goal over here is to maximize the uptime of equipment at a minimum cost. To do this, again, we acquire data from the equipment controllers. In addition to this, we also do instrumentation that is needed to acquire data like the vibration data, in some cases the motor temperatures, bearing temperatures, and so on, which typically would not be there in the equipment. So whenever there is a need for additional instrumentation, we have our automation partners with whom we work together to install the field instruments required to gather this data and then ingest this data into our platform for further analysis. So with the alarm data as well as the data that we get from the field instruments, we analyze the past failures, correlate this data with the parameters that we acquire from the equipment, and then build models that can predict failures, certain types of failures which are critical to the operations of the machine with a certain level of probability. In addition to this, we've also had customers ask us to provide them with a mechanism for tracking the breakdown service work orders whenever a machine breakdown occurs. So in order to do this, we have a mobile app that is provided to the technicians on the shop floor, which can be used by these technicians to get alerted whenever a machine breakdown occurs, and then record all the activities that they have done in order to resolve this breakdown. So the handoff between the production team and the maintenance team becomes extremely seamless. And with the data that is getting acquired from the equipment, we can also verify that the work that was done by the maintenance team is in order and the equipment is working satisfactorily. In addition to this, the module also includes features for generating alerts related to the preventive maintenance schedules that have been set up, and we also support the execution of autonomous maintenance schedules that are generally required to be done by operators at the start of the shift, at the start or end of the shift. The last module that we have in FactoryWise is for tracking of the utilities. Now, traditionally, utility consumption within a plant has been would generally be recorded as overheads in the profit and loss statement of the organization. But more recently, we have seen interest in customers to identify the exact amount of utilities that are consumed for a batch or for a production order, in order to generate the profitability data for each batch and each production order. Now, in order to do this, we hook into the instruments that are there in the plant to track things like the consumption of power, the consumption of compressed air, fuel, gas, or any other utility that is used in the production process. We capture the consumption data and then correlate that with the production data in order to accrue the cost of consumption to each batch or each production order. With this system, organizations are also able to identify any leakages within their distribution network. So in case, for example, in a compressed air network, there is a sudden drop in pressure that is identified, it would indicate that there has been some leakage within the compressed air network, which would need to be resolved. So these kinds of notifications also help to reduce any kind of losses, leakage losses within the distribution network. From a solution perspective, there are a few key differentiators that FactoryWise has with respect to its competitors. One is the speed of deployment, which generates quick ROI for the customers. Typically, we have seen pilots getting implemented within a period of 3 to 4 months from the time the PO is released. And then that gets extended into a larger engagement once the pilot implementation has been completed. Another important aspect of our solution is that we are agnostic to the kind of hardware that is there in the plant. In most plants, you would have a heterogeneous set of controllers within the plant, each having different protocols, different types of communication ports. So with the gateways that we use, we are able to support more than 250 different types of industrial protocols today. And in addition to that, wherever there is a need for additional field instrumentation to be done, we have the capability to identify the right kind of instruments, install them, and then acquire the data from those instruments. As far as possible, we do not disrupt the ongoing operations in the plant. In most cases, since we are acquiring the data, no downtime is needed from the equipment. In certain cases, customers have also asked us to modify the PLC and HMI programs as part of the implementation, in which case there might be some downtime that we need. We have worked in multiple verticals. We have our solutions deployed in auto ancillaries, auto OEMs, cable manufacturing customers, FMCG, CPG. So with our experience of working in these different verticals, we've also designed some vertical specific KPIs and dashboards which are available out of the box. This again helps to reduce the overall implementation time, which I talked about a little bit earlier. And the last differentiator for us is the fact that we have designed our solution in such a way that it can be adopted fairly quickly on the shop floor. An Industry 4.0 implementation or a connected factory implementation is also something which needs to be managed very well. Change management is a big issue in these implementations. And one of the drivers for adoption is to make sure that there is minimal entry required from the shop floor personnel, whether it's the operators or the quality inspectors. The UX of the application is designed in such a way that the operators need not enter a lot of data. And in order to help them understand the solution, the user interface is also localized. And so the operators and the inspectors can interact with the system with their native language. So with this, I would like to now go into a short demo of the product, and then that will hopefully give you a sense of how FactoryWise could help you with your connected factory initiatives. So this is the FactoryWise solution, the standard FactoryWise solution. What we are seeing here is the real-time dashboard that would typically be seen by the line managers or the line supervisors. On the left-hand side, we have the list of lines or divisions within the plant. and then each tile on the right hand side represents a single piece of equipment on the line or in the production cell. This tile shows real-time data related to the availability, performance, quality, and the OE figures for the ship. If the line supervisor is interested to see what has happened during the course of the ship, they can drill down and they can see the ship dashboard. Over here, they can see details related to how the APQ values have changed over the course of the ship. They can get details related to the various downtime instances that have occurred during the ship. In case there are any speed loss instances, those are also recorded and those are available for analysis over here. In case there is inline inspection being done, then the rejections, details of the rejections are also available over here. Now, in case there is a need to show, visualize the real-time state change of various components of the equipment, there is a graphical dashboard that is also available. This is user configurable and end users can decide the kind of visualization they want to see for each type of parameter that they are acquiring from the equipment. Now, while this is the real-time information that is coming in addition to this, the information related to all the production orders is available in the operations dashboard over here. Now, in most cases, the production order is linked to a sales order. So that linkage can also be visualized, and against a particular sales order, the status of each production order can be known to the planners as well as to the plant managers. Now, for every production order, there are these reports that are available in terms of what happened during the production during the execution of the production order. So things like the downtime analysis for the equipment while the production order was being executed, the rejection analysis, speed loss, all of this is available with respect not only to the production order, but all of this is also aggregated at an equipment level and then made available for further analysis of the decision makers in the plant. Let's just go to the standard reports that are available. So you have the OE analysis report, where you can see the analysis for the OE map for each month, each day, and each shift. In addition to this, the standard information related to overall utilization of the machine, downtime analysis, alarm analysis. This is primarily used by the maintenance team to optimize the effort that they are putting in to reduce the downtime and maximize the uptime. So the MTTR and MTBF for individual alarms in the equipment over a certain duration are plotted over here, and then this can act as a trigger for the activities that the maintenance team needs to do. Similarly, we also have TPM analysis, TPM loss analysis. So in terms of the TPM losses that organizations want to track, this is typically losses such as the startup loss, the shutdown loss, or the changeover loss, rejection loss. Organizations want to see a trend of those losses over a period of time. So that is also available in the loss stratification report. And all of the data that we are seeing here can be configured to the requirements of the organization. While this is the standard dashboard, we've also had customers ask us to integrate with an enterprise reporting system that they are already using. For example, we have done implementations where data from FactoryWise has gone into something like Power BI or QuickSight in order to make sure that all the reports that we have here are also available in the enterprise reporting platform. In addition to this, as I mentioned earlier, we also integrate with ERP systems like SAP, Infor, and JD Edwards. The primary integration points are related to the ingestion of the production plan, ingestion of the master data, ingestion of the defect masters, the routing sequence for products, and so on. And we send production data on a real-time basis, typically on an hourly basis, back to the ERP system for the ERP system to then generate inspection logs which again flow back into FactoryWise, and then the quality inspectors perform the tests against these logs to provide user decisions against these logs. So there is a complete 360-degree feedback loop between the ERP system and FactoryWise that can be implemented to provide seamless data exchange between these two systems. I hope with the short demo that we showed, you would get an idea about the capabilities in the FactoryWise platform and how we could help you with your smart factory or connected factory implementation. We would be happy to discuss this with you further. Over to you, Venkatesh.
Thanks, Subbu. It was a nice session. Hi, everybody. This is Venkatesh Bendigiri. I'm from Cognizant, and I lead the Industry 4.0 solutions and come from the Industry Plus practice. Today, I'll be presenting the Connected Factory solution, which is built on AWS IoT Stack and Apex Solution Accelerator. As we talk about Industry 4.0, Connected Industry is one of the solution being out of the Industry 4.0 solution, which enables higher margins, customer satisfaction through enabled efficient operations. To enable Industry 4.0, one of the things is we need to harmonize the solutions, the data from the various systems, get the data from the various devices from the systems, build what we call data collected, and build the right analytics to take the right decisions by the right people at the right time. So going to the what are the benefits of the connected factory? As Vasily talked about in the earlier sessions, it is improved productivity, improved flexibility and speed, enhanced safety and sustainability, and also to enable to innovate faster. So these being the connected factory benefits, the typical savings which we are seeing now is around 15 to 25% of reduction in the maintenance cost, 5 to 15% improvement in the OE, 5 to 10% reduction in spares, 5 to 20% reduction in quality and the costs. Again, this depends on case to case. This is depending on based on our solutions which we have done so far in the last few years. So now, what is Apex? Apex is our accelerator which we have built, which is built on AWS CORD solution. So what we have today here is in the system, we have got PLCs, devices, and systems. On top of that is the AWS IoT platform, and we have got the core platform, Apex core platform, the manufacturing insights, and Apex solutions, and the enterprise. What we got is the value which we're talking about, the Industry 4.0. It seamlessly delivers the insights that empowers the enterprises need to become more sustainable and profitable across the operations by maximizing asset production and supply chain performance. So if you look at the stack, there is AWS platform which provides the edge and the cloud connectivity solutions, data ingestions, the app orchestrations, etc., which is given by the AWS platform. On top of that, what we build is the Apex framework, the information models, the behavior models, the operation KPIs, the asset models, the visualization templates, which will accelerate the development of the Industry 4.0 solutions for the shop floor. So together with AWS and Apex, we come out with the best of the breed Industry 4.0 solutions, which can deploy be faster, which can have templatized, and it is ready to use, and it comes with a lower cost and a fast implementation. So today I'll be talking about the Apex framework, which is built on the AWS. So if you look at the functional components of the platform, what we have, as I talked about, we have the CORDS platform, the AWS, then the core platform, which talks about the data collection, the data ingestion, and the data storage. And then we do have a manufacturing insights, the API layer. So this is being the core platform. We use the AWS IoT, Sitewise, Greengrass, and other components of the IoT platforms to build this core platform. And then we have the Apex microservices, which are built on top of it to build the various apps on the core platform. So if you look at the various apps which are built, is the smart operations, asset performance management, optimized supply chain and sustainability. These are the various microservices which you have built on top of this, and they could be deployed depending on the need. They're all modular, are distributed, and they help us in, I'll deep dive on each one of them to showcase what a smart operations is. They're all built on the industry standards, the IS 8895, ISO 15926, use the standard communications, OPC UA, MQTT, or standard protocols like Modbus, etc. And we do have a converter connecting directly from the PLCs all the way to the enterprise systems. And again, it has the safety, security, authorization, authentications. So this view gives you a brief or functional components of the Apex built on the AWS. Now coming down to the double clicking on the solutions, we have got the various catalogs of applications which are built on AWS. One is smart operations, the APM, in-house material management, safety and sustainability are the few of the catalog applications which are available on the Apex platform using the AWS. So if I look at smart operations, it's enabling the smarter and efficient operations in the shop floor. APM is the asset performance management, which helps you in predictive maintenance, warranty analytics, spare part analytics, etc. Enabling the efficient use of the asset is the APM module does it. In-house material management is reducing the idle time, the starvation time, ability to track and trace, genealogy, etc. are the part of the in-house material management catalog. And safety and sustainability is an efficient and safe use of natural resources to minimize impact on environment. So these are the four major catalogs which I'll be talking today. And today, mostly I'll be talking about the smart operations. So if you look at the smart operations, what do you do? What are the key KPIs we do look at it? Is one of the cycle time, OE, which contains availability, productivity, and quality. And look at the quality time reject ratios, the scrap, first time pass, etc. Look at the starvation, idle time, and downtime. Help in improving the opportunity loss, okay, labor efficiency. All of these are the key KPIs which are enabled by this microservice smart operations. So what you get out of this is increased throughput and productivity, bottleneck analysis, win the hour, reduce defects, and optimizing measures and success of the monitoring the various KPIs. So this is built on a standards, ISO standards, all the KPIs which are readily available and which could be customized by the customer as on the need basis. So how do you implement? How do you go about implementing? So we have divided this into two parts: vision to design or architect, and then MVP to deployment. So we start with the discovery phase. All of them being a gated processes. We do the discovery, we socialize, align and ideate with the business, operations, and technical leadership, build the right requirements, technical technical requirements, functional requirements, etc. And then go ahead and define the reference architecture, and then help you to build the roadmap, define ROI, and shortlist the various scenarios which have to be built. Okay, and then develop the scenarios so that it could be built in various agile cycles, and then come out with a pilot rollout, industrialize the solution, and then deploy to the various assembly lines or enterprises, plants, etc., and then get into an improvement process. So this is a normal typical cycle which we try to do it. And discover to define and develop phases normally range from 6 to 8 weeks or 6 to 10 weeks, depending on the complexity, depending on the variety and the number of use cases, etc. So this is our implementation methodology which we have been using to build the connected factory solution. Okay, so let me take you an example of a major client where we have built an Apex solution of a connected factory using the AWS IoT stack. This is a major pharma company in APAC region, and where we are connected to their first plant, where we are connected to their 6 of their machines. And with the Apex and AWS IoT, we're able to get the data insights and enabling them to make right decisions and improve the OE at the moment. Today, they are able to look at the machines, ability to look at their quality issues, look at their performance issues, and able to track it, trace it, and and prevent these service bottlenecks. We also have created what I said is a rollout toolkit, which will accelerate the deployment across the enterprise. So this is one of the major use case, what you call case study, which we have built it for a major pharma plant, and similarly we have done it for other plants too, other industries also. We have done it for an OEM vendor, for a pump manufacturer. We have done it for what you call a packaging industry. So various industries we have built solutions where we could help them in OE, help them in asset performance management, help them in material insight, etc. So with this, I'll be taking you to a demo of Apex solution and walk you through the various components of the Apex solutions. So coming down to the Apex connected factory solution. So today I'll be playing the role of an nerve center engineer who will be sitting in the control room, looking at the various plants and various plants of my plants and looking at their statuses. So what I get here is a global view sitting here, and I'm looking at the 5 plants and each of them showing their various key KPIs. So if I look over on this particular plant, it shows me the OE, the yield, the wastage, etc., the key KPIs which can be defined here, and also shows the various plants, how they're trending across the various key KPIs which you have mentioned. So, and these are and it shows the RAG status of the various plants. Here, one of the plant has got the OE less than 80, and that's why it's a red status. Now I could get into this particular plant and look at it, why the particular OE is down. So what I did was I moved from an enterprise view to a global view to a particular plant view. Similarly, I could get into a plant dashboards. So what I see here is a plant dashboard showing us the various key KPIs of the particular plant. So if you see OE, it has shows OE at this moment 89, capacity utilization, scrap, etc. The various key KPIs. This data is collected from the various data sources, whether it is MES, SCADA, or it can be from ERP, quality management systems, LIMS, etc. And we collect all the data, build the right information model, right? Build the right knowledge models, and then get into the what we call the right KPIs to be showcased here. So if I click on this OE, now I get into the particular value streams. So I've gone into 3 value streams. One shows 80%, the other one 81, and the other 76, depending on the key what we call value streams. The various OE assets are shown. Then I can get into the particular OE, and I can see that the value streams of the what we call particular value stream. I see the OE, the performance, quality, availability, etc. Real time, I could see the historical data. I could see all of that, and then shows me all the asset status. So if you see, the whole hierarchy is shown here. So what we showed now, if I go back from the global view, we showed you to the enterprise view. We went into the plant view. From the plant view, I went into the what you call particular value streams, 3 value streams. From the 3 value streams, I could get into the what you call a particular value stream. From the particular value stream, I could get into a particular machine. So I just showed you so we show here the key parameter values of the assets. Then this is mostly a machine status, which is available at the shop floor attendant, a shop floor engineer, to look at the current hour, the hourly goals, the shift total, the shift goals, the actual time, the cycle time, etc. Okay, and plus the parameters, and then plus there are various analytics which I'll talk about in the next steps. So if you look at it here, we do have a maintenance scorecard which comes part of the APM catalog. So if you see here, we have got the various key KPIs. We looked at the cost, the scrap, the runtime. Okay, we got at the various work orders, the cost work orders, etc. All of them could be analyzed. Similarly, I could look at the remaining useful life. This is one of the important analytical thing which you have built on using microservices on the Apex. So here it shows me the various equipments, key what you call assets, which has got the various RUL mentioned here. So I could double click on this and get into the remaining useful life of a particular equipment. What I've seen here is we have done this for a CNC machine using a vibration data. So what we see, get the data in the time series data, this vibration data, convert this vibration data into the frequency domain, and look at the various bands, and then look at the Kurtogram. From the Kurtogram, we could go back and look at and say that, hey, the remaining useful life of this particular plant is this particular asset is at 45% based on the various data what we got. Similarly, we do the part analytics, where we could look at the mean time between failures, and we could get the using the Webull plot. What we've done is we have built the chart where you could go back and look at the failures, and in the next and look and come back and say in the next 50 days you require one gearbox, but and also looks into the ERP system, and it says you don't have any gearbox in the ERP, so it raises an alert so that corrective action could be taken. So this is one more analytics which you could build. And these are all what I'm trying to show is art of the possible, and we have got various microservices which could build and which could be added to the Apex platform. The other analytics which we have got is the golden curve, where we could look at this built on ARIMA model for a single variant, where we see the predicted value versus the actual value. Okay. Similarly, this helps you to, if there is any variations between the actual value and the predicted value, it gives up an alarm so the operator can take a corrective action on top of it. And there are again various reports, etc., which could be enabled here on this system. So let me talk to you about other things also. So as I talked about the value stream today, and today as we're talking about the productivity, so there is a thing which you could look at, the opportunity loss. So we could look at our opportunity loss for the November of the last year. So it could show me the what you call the various categorization of the opportunity loss. So it shows that opportunity loss because of the downtime, opportunity loss because of the quality, opportunity loss because of the labor efficiency. Okay, and then I could drill down into the opportunity loss because of the downtime. So I could get into the downtime details, and if I get this, it shows me the various queues. Sorry, it shows me the what I call downtime because of the various queues for that particular month. So if we go back and click on the more details, so I can get into the more details of that particular assembly line, saying that in shift 3, because of the high temperature, there was a downtime of 56 minutes. Similarly, because of the lower tension, there's a 53 minutes of the shift 3. So it could do some analysis, and we can take a corrective actions of the based on the what are the events happening on the correct events. Similarly, we do have built a heat map. So it shows you the what you call heat map of a particular downtime for a month wise and access, etc. So here what we show here is I'm showing a heat map of the quality. So what we got here is on the weekdays of particular months, it shows you the what you call the quality data. So we could go back and drill down to a particular week or a particular day why the quality was down, and look at those quality issues of that particular month or a particular week. We could look at it, and you could say that for a particular SKU, what are the quality issues, and then take a corrective actions. And similarly, we could look at the labor efficiency for a particular month or a particular year, etc. So in totally, what we told today, what we demonstrated is how we could do a global from a global view all the way. You could drill down to the asset view and look at the various OE capabilities. Look at how do you calculate the OEs, how we take corrective actions on the whether it's an opportunity loss or a downtime details or on a quality or an availability. Okay, so again, this is all templatized, and we could build this system we can configure this accelerator to any of the industries, and it really helps you to fasten the deployment, and it has got all the toolkits, it has got all the templates, etc. We could use it, and it graphics the UIs are all configurable, reports are configurable, and also the calculations are configurable based on our standard to exception design features. With this, I think I'm ending my session today.